Welcome back. Tonight, as you settle in, perhaps under a quiet sky or soft glow of beside lamp, we are going to take a slow and thoughtful journey, not across the stars, but into truth about them. We often imagine a future where humanity travels freely between galaxies, visiting distant world as easily as crossing an ocean. It's a comforting idea, an exciting one, but universe doesn't bend to imagination. Tonight's talk is about something deeper, something quieter, the harsh reality of why interstellar travel may never be possible. So take a breath, let your thoughts slow down, and let's begin. To understand why interstellar travel is so difficult, we have to begin with one simple idea. Space is unimaginably large, even within our own cosmic neighborhood. Distances are beyond anything the human brain naturally understands. The nearest star system is over 4 light years away. That's mean even light, the fastest thing in the universe, takes more than 4 years just to get there. Now imagine a spacecraft. The fastest human made object would take tens of thousands of years to reach that same destinations, not centuries, not millennia, but longer than recorded human history. And this is just the nearest star. When we talk about traveling across the galaxy, we are talking about distances so large that even describing them begin to lose meaning. Space is not just big, it's indifferent to scale. It doesn't care how advanced we become. The distances remain silent, vast, unforgiving. There's another problem, one that even more fundamental. The universe has a speed limit. Nothing can travel faster than light. This is not a technological limitation. It's built into structure of reality itself. As an object moves faster, it requires more and more energy approaching the speed of light. That energy requirement becomes effectively infinite. So, even if we built the most advanced spacecraft imaginable, powered by technologies beyond anything we have today, we would still run into this wall. We can get closer to light speed, but never reach it. And that's mean interstellar travel is not just difficult. It may be physically impossible within a human lifestyle. But there's something even stranger. Time itself begins to change. As you approach the speed of light, time slows down for travelers. A journey that feels like a few years on board might correspond to decades or centuries back on Earth. At first, this feels like a solution, but it creates a different kind of problem. You could leave Earth and return to a completely different world. Everyone you know would be gone. Entire civilization could rise and fall while you were in transit. Interstellar travel wouldn't just separate you by distance, it would separate you from time. Let's talk about energy. To send even a small spacecraft to a fraction of speed of light would require an enormous amount of energy, comparable to total energy consumption of entire nations sustained over long periods. And that's just to accelerate. You would also need energy to slow down once you arrive. There are ideas, fuel drives, antimatter engines, but even come with massive engineering challenge. dangers, and limitations. Antimatter, for example, is incredibly efficient but also incredibly unstable. A tiny amount contains the energy of nuclear explosion. Storing it safely for long duration travel is a problem we have no real solution for. The energy barrier alone makes interstellar travel feel less like an engineering challenge and more like a fundamental impossibility. Space may look empty, but it is not. At high speed, even teeny particles become deadly. A grain of dust hitting a spacecraft at a significant friction of light speed would release energy comparable to an explosive impact. Over long journeys, the cumulative damage would be catastrophic. Radiation is another issue. Outside the protective bubble of planets, magnetic field, cosmic radiation becomes intense and constant. Over years or decades, it would pose serious risk to both human traveler and electronic system. Shielding against this would add even more weight, which increase the energy required, which loops back into same problem again. Even if we solve the physics and engineering, there's still us. Humans are fragile. Long duration space travel introduce challenges we are only beginning to understand. Muscle loss, bone density reduction, physiological strain, isolation. Now stretch that over decades or centuries. Some have proposed generation ships, massive spacecraft where multiple generations live and die during the journey. But that raise difficult questions. Would people born on such a ship accept their purpose? Would society remain stable over such long time scales? And even it did. Would the destination still be worth reaching by the time they arrive? Science fiction often offers solutions: warp drivers, wormholes, hyperspace. They are fascinating idea, but they rely on physics we don't fully understand or that may not exist in usable form. Wormhole, for example, would require exotic matter with negative energy properties. We have never observed such matter in a form that could be used. Warp drivers require conditions that may violate known physical laws. These ideas are not impossible in theory, but they remain far behind anything we can realistically achieve, and perhaps they always will. Occasionally, something remarkable happens. An object from another star system passes through ours. These interstellar visitors are rare and mysterious. They are not spacecraft, not signals, not sign of life, but they are proof that materials can travel between stars. These objects drift through space for millions, sometimes billions of years before briefly crossing our solar system. They carry with them the history of distant regions of galaxy. Unlike planets or stars, interstellar objects are often small, irregular, and ancient. Their surfaces have been shaped by cosmic radiation, collisions, and extreme temperatures. Some appear elongated, others tumble unpredictably. What makes them fascinating is their origin. They are fragments, pieces of other system ejected during planetary formation or catastrophic events. In a way, They are universe's natural form of interstellar travel, but even they move slowly compared to the scale of space. Their journeys take vast stretches of time, time that human being cannot realistically endure. Studying them give us insight into distant star system without even leaving our own. Their chemical compositions, trajectories, and structure tell quiet stories about places we may never visit. They remind us that while travel may be impossible, connection is not. So, where does that leave us? If interstellar travel is impossible or at least impractical, does that mean we are trapped? Not necessarily. It means we must rethink our place in the universe. Instead of reaching the stars physically, we explore them through observation, through science, through understanding. Telescopes become our ships, data becomes our journey, knowledge becomes our destination. There is something quietly beautiful about that. As night deepens and your thoughts begin to slow, consider this. The universe does not need to be conquered to be meaningful. Its vastness, its distance, its silence. There are no barriers. They are part of its nature and perhaps part of ours. We are not travelers of star in the way we once imagined, but we are observer, thinker, listener, and that may be enough. So rest now. Let the universe remain vast and let your mind drift gently within. Good night.